Alright, so we're just going to solve a couple equations in this last video. And it's always a good idea to keep in mind the whole goal of this problem really is to isolate x. In order to do that, when you have exponents, you want to isolate the exponential expression, or basically you want to isolate your power. And what I mean by that is if you look at number 1, the fifth is only being applied to the x. It is not being applied to the 4. So only x is being raised to the fifth. So I say 4 needs to basically get out of that side of the equation because it's not part of the exponent. So we're going to have x to the fifth equals 32. And then if you want to undo a fifth power, you're going to apply the fifth root of each side. 32 is a perfect fifth. It is 2 to the fifth, so the answer is going to be 2. And because it was an odd index, we have exactly one answer to the problem, so we don't want to write plus minus 2. It is strictly positive 2. Number 2 is set up a little differently because this time the 3 is a part of the exponential expression. So it's not like we can just add 3 to both sides. That is part of the exponent. So in this case, the first thing we want to undo is the exponent. So we're going to take the quartic root of each side. That gets us x minus 3. Now since it is a quartic root, it's an even index. We want to use positive, negative. All we have to do is add our 3, and we have x solved for. Number 3 is more like number 1. 8 is not being cubed, so we're going to divide both sides by 8, and then we're going to take the cubed root of each side. There is one number cubed that gets 8, and it is 2. Number 4, 1/2 is not part of the exponent, so the first thing I want to do is multiply both sides by 2 and get 10^24, and then we're going to take the fifth root of each side. Now, 10^24 does happen to be a perfect fifth power, but if you ever want to double check, you can certainly type it in your calculator. That is the same thing as saying 10^24 to the 1/5 power. So if you check with your calculator, you're going to see that the answer is 4. Number 5 is more like number 2, where you actually have 5 as part of the exponent. So we're going to want to remove the exponent first. Since it is a quartic root, we want to use positive, negative, and the fourth root of 16 is 2. And then we just need to subtract our 5. So I'm going to get two answers. If 2 was positive, I would get -3. And if 2 was negative, I'd get -7. So both of those answers would work for x. Now number 6 does have a decimal exponent, and we'll handle that. But for right now, I want to remove everything that's not a part of the exponent. So we're going to start with the 1 and change this to an 18. We need to remove the 9. Now, I don't like decimal exponents, so what I'm going to do is turn this into 5/2. Now, we have not learned how to solve this because normally we'd say, oh, if you have x squared, you just take the square root, or x cubed, the cubed root. We have not said, well, how do you do x to the 5/2? So what I would do is change this into radical form. So it's going to be a square root of x to the 5th, and that should equal 2. So the first thing I want to remove is the square root, and I do that by squaring each side. That gets me x to the 5th and 4. And then I'm going to take the fifth root of each side. And so I will get the fifth root of 4. Now I just want to throw some caution out there. Whenever you square both sides of an equation, you do have to check for false answers. We have not learned how to do that yet, but that is something that is coming. So I just wanted to put that out there that eventually we're going to have to actually check if this answer is a false answer. And like I said, we learn all about that coming up. So just keep that in the back of your mind. Squaring both sides could create false answers, and we just need to double check them.